Hey, what's up, you guys? Welcome to another day of Living Environment. I am your teacher, Ms. Parsons, and today we're going to be looking at Unit 1, Day 6, our microscope pre-lab. And because, unlike you guys, I am here in the school building, I have a microscope that I can show you guys. So here's my show and tell piece. This is a compound light microscope, and before we begin looking at our handout, we're going to take a look at this microscope because this is what you guys would be doing if you were here in the lab. So this whole device is called a compound light microscope, and that's because in addition to the light source down here, there are several lenses that are going to compound to increase the magnification or the zoom that you have access to using your microscope. Right? So the microscopes helps us see very small things, and one practical application of using a microscope in living environment class is we use this device to measure very small things. So what am I talking about? Well, we can measure the size of a cell. We can measure the size of something very, very, very small, like amoebas or other single-celled organisms, and more advanced microscopes than this can go inside of a cell and even see the organelles. But this microscope isn't that high-powered because it only has the eyepiece and the revolving objectives to create your level of zoom. So we already started talking about the different parts of the microscope. So I'm going to go through them with the actual microscope, and then we're going to complete the matching on the handout. So down here we have our base that supports the entire microscope. That's what it stands on. This piece here that I keep holding the microscope by is the arm. The arm is how you carry the microscope, and the arm also holds the eyepiece and the revolving nose piece above the stage. Which brings us here to the stage. The stage is where you would actually set your specimen. The stage is equipped with these stage clips here, which you would use to secure your specimen in place, usually on a little glass slide. We have here the eyepiece. Obviously in its name, this is where you put your eye, where you look through the microscope. Down here we have our objectives. These objectives have different levels of magnification. In living environment, we use the medium power objective, which has 10 times magnification, and we use the high powered objective, which has 40 times magnification. But this eyepiece up here already comes equipped with 10 times magnification, and that is the compound, which we're going to talk about at the end of today's pre-lab. In addition to the pieces that we've just discussed, we also have down here the diaphragm, which you might be able to see has little holes in it. And the purpose of this diaphragm is to allow different amounts of light from the light source to go through the hole in the stage and illuminate your specimen. So shine light on your specimen. So all right, that was our little microscope tour. Let's go ahead and get annotating our document. All right, so we're looking at our day 6 pre-lab, and our aim is how do you use a compound light microscope properly, which we just talked about, what a compound light microscope is and how do we use it properly. So we're going to read this passage here and we're going to annotate it. Micro refers to tiny, and scope refers to view or look at. So a microscope helps us look at tiny things up close. Microscopes are used to make more detailed observations, which are very important in science, and measurements of objects too small for the naked eye, which is something we will do with plant cells in living environment. The compound light microscope is the most common instrument used in education today. So hopefully you guys have experience using compound light microscopes in science classes in the past. It is an instrument containing 2 lenses, which magnify a variety of knobs to resolve the picture, and it is a rather simple piece of equipment to understand and use. When I was going through the microscope tour, I left off these two very important knobs. We have the fine adjustment and the coarse adjustment. So the fine adjustment adjusts images in a more refined, meaning very tiny focus, as compared to the coarse adjustment, which adjusts objects in a more coarse or rough way. So the coarse adjustment is what you would use first, and then once you have your image almost in focus through the lens, you would use the fine adjustment. So, define, resolve. So those various knobs that are used to resolve the picture, bring into focus, make clear. So resolve the image in this case means to bring into focus or make clear. Now let's go through part B, microscope vocabulary. So we're going to match each microscope structure with its appropriate function. So you guys might remember at the beginning with our microscope tour, I talked about how the diaphragm is a disc underneath the stage that rotates to regulate the amount of light entering the scope, which is letter B. You can see that there. Now, the mirror or lamp, which is the light source for the microscope, is letter E, source of light directed into the microscope. The eyepiece, as you guys may recall, the eyepiece is where we look into the microscope. The eyepiece is letter H. It contains a lens capable of 10 times magnification, which we are going to talk about in just a moment when we get to part C, part C, calculating magnification. All right, the objectives that are attached to the revolving nose piece give us the different levels of magnification. We discussed there is low powered and high powered. So the objectives are letter C, attached to the nose piece and contain a lens. Number 5, the revolving nose piece is where our objectives are housed. Number 5, the revolving nose piece is letter F. Turns to change from one objective to the other because it is revolving. Now the coarse adjustment, like I said before, is the rough adjustment to bring objects into coarse. That is letter A. The fine adjustment is after you've already brought your object into coarse focus, then you bring it into fine focus to be more precise. It brings the object slowly into fine focus. So the rapid, quick adjustment is coarse adjustment. The more fine, slow adjustment is fine adjustment. Then the stage where you set your specimen, the stage is letter J. It is the platform to support the slide. The stage clips are letter D. They hold the glass specimen in place. Number 10, the arm is what holds the objectives above the stage, letter I, and the base is letter K, last but not least, that supports the whole microscope. And now we have part C, calculating magnification. So when we're looking through a microscope, we have the eyepiece, which always has 10 times magnification, 10 times. And this X here is very important because that is our unit. So that means the way you say that out loud is times. But it is very important that you always include the X. So the eyepiece always has 10 times magnification, but the objective varies. So our low power objective has 10 times magnification as well. And as it says here, we multiply the eyepiece lens magnification by the objective lens magnification to get the total magnification. So we see here 10 times 10 is 100x. And again, it's very important that we include that x. So for the high-powered lens, the high-powered objective, 40 times magnification. So the high-powered total magnification is 400 times. So there's some noise outside, so I'm about to stop, but as you can see here, if I'm looking through this microscope, it's this eyepiece up here that always has 10 times magnification. And down here, I have the medium-powered lens that has 10 times magnification, and the high-powered lens that has 40 times magnification. So, all right, I hope you enjoyed that introduction to microscopes. Have a super fantastic day. Don't forget to submit your exit tickets, and see you all tomorrow or next week on Zoom. Bye, guys.